Hi, my name is John and I work for the audio group here at Texas Instruments. And today we're going to go over one of our audio amplifiers from our Boomer family, the LM48511. Now the LM48511, we classify it as a filterless mono 3-watt Class D amplifier. It has two really cool features to it that I feel are. The first one is it has an internal boost converter that allows the output voltage to go higher than VDD, which allows you to get more output power than a standard Class D. The second feature is the EMI. We have a low EMI mode called spread spectrum, which allows you to get a much lower EMI measurement on the device from a switching amplifier. So now, not only does TI offer you samples, but we'll also offer you a sample board or a demo board where you can actually use the part that it's meant to hook up as. So let's go over the demo board. The first thing that you want to look for is the parts right in the middle. There's nothing being hidden. The parts right in the middle of the demo board, and you've got support components around it. Now we have programmable ability with the jumpers, and then we also have inputs and outputs. So let's go over the inputs and outputs. There's VDD and ground. For our demonstration today, we're going to be using 4.2 volts VDD, but this part can be ran anywhere from 3 volts to 5.5 volts. The second thing are the inputs. We have a plus and minus input here, and we have two ground connections that are supplied for you on the inputs. And the output is a bridge output. You can use it for an 8-ohm speaker, or you can use it for any piece of test equipment you choose to hook up to it. Today we are running an 8-ohm load on it, and we're also connecting it to our Audio Precision audio analyzer. We're supplying our input from our Audio Precision audio analyzer also to run sweeps, and we'll show you that in the demo later. The programmability is right here. This part has the ability to shut down both the boost converter and the Class D separately, and that's done here. The boost converter has a high and low control here that you can shut that down separate from the Class D. The Class D shutdown is done up here, which you can go high or low with this jumper. This jumper over here will put it in the low EMI spread spectrum mode, and this jumper here, which we'll demo later, will put it in the high or low feedback, which will give you two different output voltages for the boost converter. So now that we've covered the board, why don't we go ahead and start the demo. So the first thing I'm going to do with the demo is turn the device on. So I'm going to turn the power supply on, and we've got it set to 4.2 volts. And right now, the boost converter isn't doing anything because it's not on. So I'm going to turn that on first. So we're going to come over here. And now you notice that it went from 4 volts up to 8.2 volts, the maximum output the boost converter can do. The second thing I'm going to do now is to turn on the Class D switching amplifier. I'll do that by changing this jumper. And as you notice, we now have the switching waveform on the oscilloscope of one of the outputs. Now this is in its fixed frequency mode, which may or may not give you a high EMI reading. To help you with your EMI, this part has a fantastic feature called spread spectrum, and I'll demonstrate that right now. Now you notice we're not at a fixed frequency mode anymore. We're at a point where we're sweeping many different frequencies, which overall will lower your EMI emissions and give you a much better EMI performance. So now that that's demonstrated, I would like to demonstrate how the power is applied with the boost converter, different output voltages. The first thing I would like to show you is now that the boost converter is at the maximum output voltage, I'm going to do a sweep of THD plus noise versus power. And I'll do the first sweep now. Now, you should notice that at 1% distortion, I've got 3 watts coming out of this device, the maximum output voltage, or the output that this part can do. Now, if I lower the feedback select and bring it down to a lower boost voltage here and run a sweep, you will see that I get much lower power at 1% distortion. I get 1.5 watts versus the 3 watts. Those are the two output or feedback configurations that are offered on this part. Now, if you have any more questions on how this part operates, you can go to the website listed on the screen, and that will give you the ability to download the data sheet. And something else that I found very useful was the evaluation board user's guide. These are both found on the website listed on your screen. And that's it for today, so thank you very much and have a great day.